Okay, we're going to look at Chapter 1, Lesson 4 in Advanced Algebra, looking at solving inequalities, and then we'll look at compound inequalities. And I'm going to break that up into two videos where we will look at solving inequalities first and graphing their solutions, and then go ahead and look at compound inequalities. So let's look at equations and inequalities and how we solve those and how we graphically represent those. So far we've been dealing with solving equations, and we might come up with an answer like x is equal to 4. Well, how does that look graphically? How do we represent that graphically? Here's our algebraic answer. What would it look like graphically? So on a number line, we can take a number line, and we'll use a straight edge to do that. And we go ahead and put 0 on here. We have an origin, so we have a point of reference. Now 4 is to the right of 0, so we can put 4 out here. And x is equal to 4, so I put a point on 4, and that would be the graphical representation of the answer, x is equal to 4. And it's just one point on the number line, the number 4. When we begin to look at inequalities, greater than and less thans, we're going to have a lot of solutions that could work. So how do we represent those graphically? So why don't we go ahead and take a look at those. So let's say I had the expression x greater than 4. Okay, so now the solution is I can pick any number for x as long as it's greater than 4. Well, we have an infinite number of numbers to look at, 5, 6, 7, whatever you want, as long as it's greater than 4. How do we represent that graphically? So again, we're going to use a number line. So we'll use our straight edge and draw a line. And then we always want to put an origin on there, so we have a point of reference. And you only need to put the number that you're using on your graph. So we're only using a number 4, so we'll just go ahead and put 4 here. I don't need all the 1, 2, 3s and all the other ones. It's just a waste of time for our purposes. So we're looking at how do we represent then on this graph the numbers that are greater than 4. Well, 4 is not included, so hopefully you remember from earlier algebra course that we put an open circle on the number when it's not included in the answer. I can't use 4 because 4 is not greater than 4. 4 is equal to 4. And then I'm looking for the numbers that are larger than this, and the larger ones would be to the right. So you go ahead and just put a little hoodookie, and put a little arrow like that. And so this would be the graphical representation of all the numbers that are greater than the number 4. Well, what about less than? Let's do like x is less than or equal to -2. Okay, how would we represent all the numbers that are less than -2? So again, we're going to use our number line. So I want you to use a straight edge, and I want you to put your origin on those so we have a reference point. Now, -2 is to the left, so we put -2 here, and now we're looking for all the numbers that are less than or equal to. So because 2 is included, it can be equal to 2, that's okay. We put a closed circle here. And now where are the numbers that are less than this? Well, these would be the numbers to the left. So again, we put a little hoodookie up here and we go to the left. So this would be the graphical representation of the numbers less than -2. Okay, so that's how we want to show our answers on a graph and number line once we've solved the inequalities. So let's go ahead and look at solving these inequalities, and how do we do that? So we're going to look at solving inequalities, and really you remember when we solve an equation we're looking for the solution. We're looking for the number, or in this case the numbers, that are going to make the statement true. Okay, now inequalities, as we talked about, have many solutions, and the way you solve an inequality is you use the exact same properties that you do when you solve an equation. So all those properties of equality that we talked about in earlier lessons, where you can add the same thing to both sides, subtract the same thing from both sides, you can remove fractions, you can gather variables to one side, all of those rules apply. You do the exact same thing with inequality. There's absolutely no different at all. There's just one exception that you have to remember. Okay, and this is really it is the only difference. And the exception is this, is that you have to reverse the inequality sign when you multiply or divide by a negative number. Okay, so you look down here in this box, it's in your book, the properties of inequalities. You'll notice that all of those are the same. If you're dividing by a negative number, so in that very last step, and those steps we've been talking about all year long, the last step is always division. If you end up dividing by a negative number, you need to reverse that inequality sign. Okay, so dividing it, you can reverse the inequality sign. Now there is a shortcut and a way to avoid that, and that is to make the variable always positive, but if that works for you, you can go ahead and do that. And I'll show you one of those just so you see, but the rule is you have to reverse the inequality sign. So if I'm taking this expression here on the right, negative 3x plus 7 less than 4, and I want to solve it, so I do the same properties I did before. I distribute and gather like terms if I can on each side. Okay, nothing to do here. I remove fractions. No fractions to remove. I get the variable by itself. So here's x. I need it by itself, so I'm going to subtract 7 from both sides. That gives me this. Now you'll notice now I'm going to divide. Notice that the number I'm dividing by is negative 3. Because that number is negative, I'm going to need to reverse the inequality sign when I do it. Okay? So I go ahead and do my division, and notice that I reverse the inequality sign. Here it was like this, then because I divided by a negative 3, it changes to this. So my answer is x is greater than 1. Okay, that's the only rule you have to remember. So write that in your notes, make a mental note, highlight it, circle it, put a star by it, exclamation points, whatever it takes. Remember that when you divide by a negative number, you must reverse the inequality sign. Now, I want to make one thing perfectly clear. Let me give you another example. Okay, let me go to this one here. Let's say I had 3x less than negative 3. Now, I'm dividing by positive 3. In this case, I do not switch the inequality sign. Notice I did not. It's because the number I'm dividing by is positive. So as long as that's positive, okay. It doesn't matter if this one is negative or not. It just remembers, it just matters if the number I'm dividing by is negative. And in this case, I was dividing by positive 3, so the inequality was not reversed. Okay? And then once you have your answer, then you would go ahead and graphically represent that. So if I was going to do x is greater than 1, then I would use my number line. I'm going to put it right up here in the middle. I know it's kind of weird. But, okay, an origin. We find the number 1 here. X is greater than 1. 1 is not included, so it's an open circle. Make sure you label it. And then greater than, numbers larger than this would be to the right. So we just go up and indicate that you go to the right. Any of these numbers up here to the right of 1 will make this expression that we started with true. Any number that I choose, that will make it true. All right. Now there is one example here. It's one situation where, these are a couple examples I'm not going to work through right now. Let me work through just the one example, and then I'll talk about the last one. So here we have an example, so solve this inequality. So we're going to follow our steps. So remember, we distribute and then simplify on this side of the equation, all right? So we distribute, so 6, 5 times 2 is 10, and then distribute this, minus 5x, less than or equal to 41. So remember, we distribute and then simplify each side separately. So as I look here on the left, I notice that I can combine the 6 and the 10. So I'm going to get 16 minus 5x less than 41, or equal to. Now, I'm going to do the little trick here that you can do. Notice if I go to get this variable by itself, the negative sign, it would be negative 5x if I move the 16. Well, rather than having to remember to divide by negative, what I can do is move this to the other side, making it positive. Okay, so if I add 5x to both sides, that way when I get to the end, this is going to be positive. I don't have to remember the inequality or to reverse the inequality sign. I just did it by moving it to the other side. Okay, so you can either keep the variable positive and then you don't have to worry about that rule, or just remember the rule. All right, either way. So I'm going to subtract 41 from both sides, so that's going to give me negative 25 less than or equal to 5x. Now notice I'm dividing by 5. This is a negative, so do I reverse the inequality sign? I'm dividing by a positive number, so do I reverse it? No, I don't reverse it because this number is positive. It doesn't matter that this is negative. So x is greater than or equal to negative 5. Now, when the x is on the right here, you have to kind of read from left to right, or I can apply a version of the symmetric property. I can change everything. Notice that the wide side is with the x. So if I want to make this as a matter of convention and reverse everything, then I reverse the sign. So you can see here's where I actually reverse the inequality sign. All right, so I have x is greater than or equal to -5. So then to graphically represent that, I'm going to go ahead and draw my number line. I'm going to put an origin on it. I'm going to look at -5, and that's to the left here. Now I'm looking for x's that are larger or equal to that, so that's a closed circle because I can use 5 equal to, and the numbers greater than this would be the ones to the right. So I have, this would be the graphical representation of my algebraic answer. Okay, now there are a couple of scenarios that I want you to figure out in your book. I want you to read in your book, and we're going to discuss them in class. You're going to discuss them in your groups, and here's what I want you to do. Find out in your book what happens when you are solving your equation and solving your inequality and the variable goes away. In other words, all of a sudden you're adding and subtracting the same thing on both sides, and then all of a sudden, for some reason, all the variables in the problem are gone. There's zero. There's none. So you just end up with a number less than another number or a number greater than another number. What does that mean? Okay, so I want you to try to find it in your book, write it in your notes, and then we'll discuss it when you get to class what that means. Okay, so this is video 1. Make sure you check out video 2 in dealing with compound inequalities. All right.